Hello everyone, this is going to cover classification of joints. That's chapter 9.1. Joints are also called articulations, and basically joints are any place where adjacent bones or bone and cartilage come together. They can be classified both structurally and functionally. Structural classification of joints are based on whether the adjacent bones are connected by connective tissue or whether they articulate with each other within a fluid-filled space called a joint cavity. Functional classifications describe the degree of movement available between the bones, ranging from either immobile, slightly mobile, to freely movable joints. And so we'll talk about all of these right now. The first example are fibrous joints. Fibrous joints are where adjacent bones are united by fibrous connective tissue, mainly collagen. These joints are going to be fixed or basically immobile, and you can see an example on the left. The sutures that connect the bones in your skull, you probably wouldn't want those to move because they need to protect your brain. And so, once again, those are called sutures. The next example are cartilaginous joints. The bones that meet at cartilaginous joints are going to be joined by what we call hyaline cartilage, which, if you remember, is the most prolific cartilage that you find in the human body. But they can also be joined by fibrocartilage. They're going to allow for slightly more movement than the fibrous joints, but not free range movement. And an example of these are the intervertebral discs that you find in your spinal column. So they'll allow slight movements between two of the vertebral bodies in your spine, but not free range movement. But if you add up and basically look at the entirety of the spinal column, there is pretty good movement. You can move your spine left and right, and but it doesn't have free range movement, so that those discs are completely allowed to just slip and slide all around. So a pretty good medium ground. The last type of joints are the synovial joints, and these are the most common. They're the bones in a synovial joint. They're not going to be directly connected to each other, but instead they interact within this joint cavity called a synovial cavity that's going to be filled with this lubricating fluid called synovial fluid. Synovial joints are going to be the joints that allow for free movement between the bones, and like I said, they're the most common. You have them in your shoulders, your knees, your neck, your wrists, anywhere you can really think where you've got free range movement of where two bones would meet. Those are the synovial joints. Now let's talk about degrees of movement. The first are the synarthroses or synarthrosis, are going to be the immobile or nearly immobile joints. Like I said, they're important at locations where bones are going to provide protection for internal organs. Namely, I can tell you, is your skull. You don't want that to be moving at all. You want that to be basically a capsule that's going to protect your brain. Both fibrous and cartilaginous joints can be synarthroses. The next example are the amphiarthroses, or basically joints that have limited mobility. And once again, fibrous and cartilaginous joints can be amphiarthroses. The last are the diarthroses, which are the freely mobile joints. These type of joints include all of the synovial joints. So synovial joints are the freely moving joints. We call those diarthroses. Most diarthrotic joints are found in the appendicular skeleton, and thus that's what gives your limbs that wide range of motion. Diarthroses are classified based on how many ways that they can move. So uniaxial means there can be movement in one plane, biaxial means movement in two planes, or multiaxial means that they are allowed movement in all three anatomical planes. Those are transverse, frontal, and sagittal. Let's take a look at what exactly that means. So a uniaxial joint, like I said, allows for motion in a single plane. Usually around a single axis, right? So one example is the elbow. If you move and bend your elbow, it can go only one way, right? It goes bending and you can straighten it. That's one movement in one axis. A biaxial joint, look at your knuckles, they can move in two planes. You can think of moving your knuckles by closing your fingers and bringing your fingers down to your palm, but you can also spread your fingers away from each other and bring them back. So they move in that plane and also in the plane of closing your hand itself. So that's two planes. And then if we look at something like the shoulder and the hip joints, we call those multiaxial joints. They allow the upper or lower limb to move in an anterior posterior direction and a medial lateral direction. So those are two. And then the third plane is the addition of being able to rotate the limb on its long axis. So think about moving your leg, that you can slightly move it away from the midline of your body and move it back. You can also kick it in front of you and behind you, and you can kick it out to the side. And so that's three ways in which that joint can move. If you take a look at what your hip bone looks like, it really looks like a ball in a socket where you can move it this way front and back, this way left to right, and this way you can rotate it a little bit away from the midline. And so that's all I'm going to talk about today. Look forward to the next couple of videos going a little bit more in depth.